Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I'm sorry I haven't been around too much lately. I've just had a lot of things to do in real life. I'm taking some courses and I've got some family things that I'm dealing with. Today I want to talk about flat Earth confirmation bias. Now, one of the things that is very classic for the flat Earth is that they have this silly fantasy narrative of theirs that they're trying to support. And what they do is they go out and do experiments to try and find evidence that seems to support their idea, at least in their own minds. One such example is Ranty Flat Earth. Ranty Flat Earth constantly puts out globe proofs and somehow tries to interpret them to mean that the Earth is flat. I've never really been able to figure it out, but I'll tell you, I'll deal with the material. So let's have a look at this particular one where he took a fish tank, some sugar water, a pot, and a paint can, and tried to show that the Earth was flat and sunrises and sunsets were caused by something called sinking, which is a type of refraction. So let's cue up the music and get going. Well, let's go ahead and start off with an explanation of what atmospheric refraction truly is. The Earth's atmosphere is thickest nearest the surface, and then as the pressure decreases as we go up, the atmosphere becomes thinner and thinner. So as a result, there's a density gradient in addition to a pressure gradient. And again, the denser air is closer to the surface. Now, this can be very important when we're dealing with long observations with warm air over cold water. There will be a layer of dense air cooled by the water right next to the surface of the water up for a couple of feet. And as a result, you get a lot of this refraction. So what happens with refraction is, as you can see from this illustration, you see the direction to the sun, and a ray of light coming directly from the sun would follow that solid red arrow. However, as it hits the denser areas of our atmosphere, it's bent downward. And by the time it hits our eye, it appears as though the sun is actually higher than it is. This is normal refraction. It is possible to get something called sinking, and that involves a temperature inversion where you have very cold air over a warm surface. The light will actually bend up, and objects will appear to be lower than their actual location. That's a rarity, though. Normally what we see is something called towering, where images are stretched in the vertical dimension, or we'll see looming, where the entire object appears to be higher than it actually is. So let's go see how Ranty tries to show that sinking is responsible for sunrise and sunset every single day. So just so it's clear, I'm not putting words in Ranty's mouth. Let me go ahead and let him present his results in his own words.
These two images were taken in different density gradients. The first image on the left was taken after adding 1450 ml of sugar and 1.5 litres of water to the water already in the fish tank. The second image on the right was taken after an additional 2,000 ml of sugar and 1.5 litres of water were added to the fish tank. You can see that the pot I placed in the tank lines up pretty well in both images, and the cumulative effects of the density gradients have not had enough length to make the object move its visual position. However, when you look at the tin of paint in the right-hand image in the background, you can see that it is sunk in relative position to the pot. This proves that on a flat plane with a density gradient, distant objects will fall out of their expected positions and appear lower in the image. This very simple demonstration has proved Miles Davis and co. wrong, and proven that sinking is indeed a very real reason as to why we see things the way we do, over our wonderfully flat plane. I've been Ranty Flat Earth, and I'll see you all in the next one.
Now, the entire purpose Ranty did this experiment was to disprove this image from Miles Davis. Now, in this case, his camera height was 210 meters. The top of those bridge towers was also 210 meters, so exactly at the same height as his camera. And the mountains in the background, even though they are more than twice to even 3 times higher than that 210 meters, they appear to be below the top of those bridge towers. This is absolute proof that the Earth is not flat. It is spherical, and the curve drops away from you as you go 80 kilometers into the distance. Ranty was doing his darndest to try and say that this is not Earth curve. What this is simply sinking due to refraction. And he set up this experiment and thought that he got some results that indicated that. Now, originally I was going to debunk this myself, and the approach that I was taking was manipulating the focus on the camera and the distances involved to reproduce these effects, because that's what I thought that Ranty had done. But it was actually a lot simpler than that, and Flat Earth Dogma, another YouTube creator, figured it out and did an excellent debunking video on it. Now, this is a two-part video, and Blue Marble Science and Miles Davis highlighted part 1. I'm going to highlight part 2. So let's go ahead and have a look at Flat Earth data. And if you get a second, stop by his channel. There's a link in the description, and give him a like and subscribe, because he put a lot of work into this. So here's the video. You can see the mirror from Blue Marble Science. Let's go ahead and listen to Flat Earth Dogma.
So I left a comment on Ranty's video telling him about my last video. And Ranty replied with, "Seen the shit analysis. Shame you can't understand the simple stuff. Try harder next time." Now, on one hand, that was a little odd, because I just pointed out a whole lot of looming going on in this photo. But Ranty does have a point when I raised the right photo later in my video to align the top of the can. And the reason I did this is I thought I had evidence that he had cropped the photograph. But after looking at more of his video evidence on this topic, I can say that I made a mistake, and he did not do this. So the reason I thought he might have been cropping his photograph is because of what was going on in this area. If you look at the ruler on both sides, we see that there is no change between the number 4 and the number 5. But why is this label over here stretched higher than it is on the right? And there was actually a few comments about this too. But this comment by Crozy on Blue Marble's channel gives us a clue. And he says, "I did point out to Ranty about the looming dot. He said the image on the left that is taken as a reference was during the mixture still not settled down." So if the mixture hadn't settled down, that could explain why we see a refraction difference in this area. And when I play Ranty's video, you're going to see these objects wobble up and down. Of course, this brings up another question. Why didn't Ranty use plain water as a reference? This way he would be comparing the density gradient to plain water with no density gradient. And you have to wonder, did he document this, but didn't use it because it didn't fit his narrative? Now here's another short 54-second video by Ranty that was released later on the same day. And in the description, he said, "Quick time-lapse showing the effects of sinking. More sugar water was added to the tank, creating a density gradient." So Ranty starts with a sugar water solution on the left, and then he adds more sugar water to the right, and he says this creates a density gradient. Of course, the funny thing is we see no obvious refraction in the right photo. The 4, 5, and 6 in my ruler align with the 4, 5, and 6 in Ranty's ruler. And I really don't even need to add a ruler to the left photograph because the refraction is plain as day. So we can see a definite case of looming because this section on the can on the right is raised higher over here on the left. And we also have an example of towering, which of course is related to looming, but the difference being is that the object is stretched higher. And in the real world, it is not uncommon to see both of these phenomena at the same time. So we start with a clear case of looming and towering, and Ranty just dumped in another load of sugar water, which of course stirred everything up and destroyed the existing density gradient. Now look at all the wobbling up and down due to the variations in refraction. Now what is happening is that this is actually settling down into a constant gradient from top to bottom. But of course with time, this will reform into a brand new density gradient.
Now I want to make sure that you understand exactly what he said because I think that there was a little bit of lack of clarity there. When Ranty originally had the tank with the sugar solution in it, there was a density gradient. The denser sugar water was at the bottom, the less dense water was at the top. When he poured in the additional sugar water solution, what he did was he mixed everything up. He didn't reform a density gradient, he created a uniform density in the water. And as that settled out, you saw the shimmering and the stretching and contraction of the various labels on the can. Now, this is an unstable solution at first, but the bottom line is there's no longer a nice density gradient from low density at the top to high density at the bottom. So let's let Flat Earth Dogma continue.
Now, I don't have a fish tank, but I'm going to demonstrate this with a brown sugar solution in a glass. So you can clearly see the density gradient. But when I pour in some water, it mixes everything up, which of course destroyed that density gradient. So was the apparent sinking caused by a density gradient? Of course not. Ranty actually destroyed that gradient by adding more sugar water. Now, 2 days later, Ranty has a live stream, and a guest is pointing out the obvious. And that is in regard to these 4 photographs where you see decreasing refraction from the top to the bottom.
You're saying the cans disappear behind the plant pot?
Yes, well, that's what has happened. I'm not saying
well,
it.
I'm saying it might have happened the other way. Maybe it was always behind it, and your sugar solutions made it stretch up above it, maybe.
This was the strongest solution at the bottom. So the more solution that I kept putting in, I kept putting more sugar solution in. Yeah.
You're saying it started by looking all stretched, then
no,
more solution made it go back to normal behind the plant pot.
No, the first image that I took up the top, right, this very first image up here, was taken with...
That looked well stretched, though. Look at that tape.
Yeah, as I say, when I first did this on day 2 or what have you, I think this was after it had settled down overnight. So all night long it had been settling, right? And there was, I believe, 3.5 kilograms of sugar in the tank on this particular image.
Instead of me pulling up discrepancies, your conclusion is sugar solution makes things...
No, sugar solution increased the density inside the tank, and the increased density in the tank created the visual thing that you're seeing here.
Unbelievable. So Ranty not only admits that the solution had set overnight in the photo on the left, but he also admits that there's obvious stretching or refraction. But he's also changed the story a bit, because now he is claiming that it is increased density that is causing the sinking. Well, unfortunately, that guest left shortly thereafter, because what he should have done is said the obvious. Ranty, that is not sinking. It is looming that is happening in the first photograph. Now, this is something else to consider. This was a comment that Walter Bislin made on Blue Marble's mirror of my video. And he says at some point the water is saturated at the bottom so much that the gradient gets lesser when we add more sugar. The density may still increase, but the gradient decreases. So let's start with a sugar solution where we have a density gradient from top to bottom. So you add more sugar, let it set overnight, and it's going to get to a point where you're going to have a saturation on the bottom with little or no gradient. And of course the saturated area will get larger when you keep adding more sugar. And as Walter correctly says, only the gradient causes the bending of light, not the magnitude of the density. So is this really a controlled scientific experiment or confirmation bias? Well, take a listen to this live stream with Ranty and another flat earther.
Well, this is supposed to say primer, and you see how low down the wording is in relation to the top of this obstruction, this pot that's in the foreground. And then look at the start of the video. Look where it started off. Look there. It's way... You can read it all. You can read the words primer. And then when you get to the last image, like down here, you can only read prim. You can't see the ER. That's completely sunken behind the pot.
Well, that's the part that got me so pumped when you put out your video earlier today, and I watched it. That's the most obvious change that you can see is that word primer going down. That is something being obstructed from the bottom up. Period.
Yep, absolutely.
That's not scrunching. You can call it whatever you want,
Andy,
but that image is sinking behind that pot in the foreground.
Yep.
Sorry, but only in a flat Earth echo chamber could you ignore the obvious. I really don't even need to add these rulers to understand that on the photo on the right we see little or no refraction, and we see obvious refraction on the photo on the left. So how could anybody make the claim that this is sinking when what we really have is a case of looming on the left photograph? So the reality is that even though Ranty taped a ruler in his experiment, he could not identify examples of refraction. Therefore, he didn't understand that when he poured in more sugar solution, he actually created a temporary solution with no gradient. He also assumed that adding more sugar was the equivalent of making a density gradient. So Ranty assumed that he had documented sinking, and in one video he said it was caused by a density gradient, and in another video by increased density. Which of course brings us back to the question, why didn't Ranty use plain water as a reference, which would have correctly shown looming? So my conclusion is that we have another case of confirmation bias. It's shocking.
Well, so once again, we have another example of flat Earth science. You do an experiment which involves apparently just doing something without having any understanding of what you're doing. You get some results that you think somehow support your narrative, and you run with it. This is a classic confirmation bias. Now, there's a couple of problems that you run into with this, and the main one is the scientific method. And this is something that Flat Earth Dogma and the other reviewers haven't really hit on too much. Scientific method is a basic approach to science. And let's go ahead and have a look at it here. First of all, you have to have an observation that you wish to explain, a question. So, why does the sun set? How did Miles Davis have those mountains appear to be lower than the bridge in the background? Okay. Ranty proposed an answer to that question, and that is that it had to do with sinking due to refraction. The problem that he ran into is he didn't go through with that and try and come up with some sort of a mechanism that explains that sinking. And he didn't look and do any research on the known mechanism of refraction. However, he did hit the next step, and that is that he made a prediction. He made a prediction that if he added sugar to water in a fish tank, it would cause sinking, which would mimic the results from Miles Davis's picture. And then he went out and tested it. At least he tried to test it. He made an effort. All right, that's better than we normally see in the flat Earth. But here's the problems that you run into. He doesn't understand what refraction is caused by. In refraction, light is bent towards the denser medium. So with a density gradient, such as the original photograph, you're going to have denser sugar solution at the bottom of the fish tank and less dense sugar solution above it, and that change will occur in a gradient. As a result, light beams that are coming in reflected off of your object will be bent downward towards the denser medium at the lower part of the fish tank. The result is that objects will be loomed up. They will appear to be higher than they actually are. In order for the objects to demonstrate sinking, you would somehow have to reverse that density gradient. The denser material would be at the top of the fish tank and the less dense material at the bottom. That would result in light being bent upward and the objects appear to sink below their actual position, which is what he's trying to demonstrate. The other thing is, if you don't have a density gradient, there is no looming or sinking. Whether your solution is pure water or it's gelatin, as long as it is uniform throughout the fish tank as you look through it at 90 degrees, you're not going to see sinking, looming, or towering, just as you look through very dense glass through a window. So not only do we have another weak attempt at science by the flat Earth, with a complete lack of understanding of the basic processes involved, and a misinterpretation of the results, but when the results are actually interpreted correctly with the mechanism of refraction, it demonstrates exactly what we expect it to, and that's looming. So, thank you again, Ranty, for proving the spherical Earth. And this is Bob the Science Guy signing out from Northern Michigan. Thanks again for stopping by. Make sure you hit that like and subscribe. We have memberships, merchandise, and a Patreon if you want to support the channel. Now I've got to get back to some other things, so I'll see you again soon.